In 1980, 3 siblings were each given $1,000 as part of the inheritance from a deceased uncle. The siblings agreed to invest their money individually and come back years later to see who had amassed the most fortune. So those of you who actually have siblings, this is typical, right? So see who's the best after years, okay? If you don't have siblings, I can't really say that's your fault because it's really not, but, you know. So the first sibling, the oldest brother, Alan, and every time I read this, I want to be like, Alan, Alan, Alan.
Okay.
And some people get it, and the rest of you are looking at me like I'm crazy, and that's true. The oldest brother, Alan, put $1,000 into the bank. Each month, he would add $62.50 to the account, or $750 per year. The sister, Bernice, invested her $1,000 in various money market accounts and earned 12% interest each year, which is compounded annually. Carl, the youngest, put his money into technology stocks. Their value climbed according to a parabolic curve until it peaked at $20,600 in 1994. By 2008, the stocks had fallen back to their original value of $1,000. So first thing we have to do is we have to look. You saw what I just read. You read along with me. And then there's graphs over here. We have to figure out which financial history goes with which graph. Any ideas? Don't judge people with the name of Bernice. I'm sure they're very nice people. What you got? Parabola is easiest one to find because it says, right? According to a parabolic curve, it says. So Carl is the parabola. Okay, we have 2 other people, Alan and Bernice. So this is Carl. So you think that Alan is the line. Why do you think Alan is the line? He constantly adds the same value every month. So that would be his slope, right? His rate of change. Okay? So Alan is the line. Can anyone guess the last one? I know it sounds like it's a trick question because there's only one more person and one more type of shape on the graph, but you got to tell me what it is. Okay, it is Bernice. Obviously goes with this one. But what is it? It is a curve. What kind of a curve? It is nonlinear. Thank you. What did you guys say? Nothing? Is it a what? Nope, it's not a log. Why do you think it's an exponential function? Because of the interest, right? It's increasing 12% each year. Remember the stuff we just did? What did the equations look like? It was raised to a power, wasn't it? That would make it an exponential function. Okay? The next thing we have to be able to do is we have to be able to write the equations for each one of them as well. What do you think we ought to try first? Probably Alan's is the easiest, isn't it? If we know his is a line, it's going to look like y equals mx plus b, m being the rate of change and b being the starting value, right? Do we know either of those for Alan? Yes. What is it? A of x is going to equal? He started with 1,000. What's his rate of change? $62.50 per month. Or we could do $750 a year. So if I put 6250x or 750x, we're going to get exactly the same thing? No, we won't. We have to figure out which one we're talking about. So we could actually read the directions. Here, let x equal time in years since 1980. So what needs to go as my multiplier? 750. Excellent. For most people, the next easiest one to write is Bernice's. Because they remember back, because it was just a couple weeks ago that we talked about the fact that when we're writing exponential functions, we have to have a starting value. When we're talking about interest, if we're increasing our value, does it seem like she's increasing her value? 12% each year, then we have to say 1 plus that percentage. 1.12 raised to the x power. And then we get to Carl. Y equals x squared is the parent function. That's very good. Okay? But we know this is not a parent function parabola, first of all, because we can see the graph of it, and it's clearly upside down and way over from where it's supposed to be if it's a parent function, right? So we have to remember back to September or October when we did this. And some people have a hard time of that. So how about if I walk you through how we do this again? Will that work? So from our home screen, from here, we're going to make a new document. No, we don't want to save our old one. We want to make a list and spreadsheet document. Our x value is going to be what? Time in years. So time or years. I'm going to put years because that makes a little bit more sense to me. You want to put something else? Go for it. What's our y value going to be? Money, right? M-O-N-E-Y. How many points do I need to find the equation of a parabola? 3. At least 3, right? Do I have 3 points in this paragraph about Carl? Tell me what they are then. So I have a value of 20,600 and I have a value of 1,000. I have 2 thousands? Oh, 1,000 at the beginning and 1 at the end, right? So is that 3 points? Yes. Okay, so what do I put in for years? 1980? Except, remember what it says. X is time in years since 1980. So it's 0. At 0 years, or in 1980, I had Carl had $1,000. For the record, in 1980, I was 7. And I did not have $1,000. Because I was 7. Okay? Then what? What's the next years that I know? 1994? Do I put in 1994? What do I put in? Why 14? How many years past 1980, right? 14 years after 1980 is 1994, correct? $20,600. And then what? 2008 would be 28 for my x value. My y value is 1,000. Okay? Are we okay up to here? You remember that? Are you recalling any of this? This is not me teaching you how to do this the first time. This is reminding you how to do it. Yes? Okay, so now I need to add a page. So Control Doc to add a page. What kind of page am I adding? Data and statistics. Remember this? I need to take my cursor down to the bottom of the page and click it My x value is years. I need to take my cursor over here to the side. I'm holding up, waiting a minute. Yes, we added a page that was data and statistics. What? Go on. Are we at the same place? They should. You already went to the side? Yeah, and she added money. Is that good? You only have 2 points here. Oh, you didn't ever hit enter. That's why. That's okay. Time and money. Better? Okay. So now, how do I find the equation? Menu, analyze, regression. What kind of regression are we finding? Quadratic. Bam. Negative 100 x squared plus 2800 x plus 1000. And I got that straight from the calculator. I just read it straight from the calculator. Okay? It's not really random at all. It's very specific. Check the equations using a calculator with the domain of 0 to 28. Okay, so what we need to do is let's go ahead and add another page that's a graph. And in y1, let's put our first equation, 1000 plus 750x. Oh, yeah. Earlier, this kid was like, I wrote mine different. I wrote mine 750x plus 1000. What did I say? Okay. You're clearly better than me. His was just an exactly slope-intercept form, and I just wrote it according to how we thought, right? So I'm going to hit tab again, and I'm going to put in my next equation, 1000 times 1.12 raised to the x power. Oh, so I must have broken it, right? So because it didn't show up? No. We will. We're just putting them in for right now. So tab to get my last one. What's up? Yes. Yeah. Negative 100 x squared plus 2800 x plus 1000. Okay? Now, something that happened on one of the videos that I smiled about because they got something like this and they were like, oh, the lines must be parallel. Well, first of all, only one of these is a line, isn't it? What did they forget? They forgot the window, right? They forgot to change the window. So let's go ahead and fix our window. Now, it tells us very specifically that our window settings need to go from 0 to 28, right? Our domain needs to go from 0 to 28. And how did they count? By 14s? It doesn't tell us what to do for our range. Is there any context clues I can use here? What's our graph that we're given go to? Looks like 0 to 25,000. Did I push the 0? That's funny. 25,000. And how did they count? 10,000. Oh, I put them backwards. 0. That's what I didn't hit tab or it didn't go or something like that. To